Staff research at Site Department, and it's my great pleasure to introduce Professor Harmanpreet Kaur. She and I actually were in the same PhD program, so it's actually, double nice. Her research focuses on human-centered AI explainability and hybrid intelligence systems. Specifically, she's dedicated to both evaluating existing systems and seeing if they actually meet all those purposes and requirements, as well as designing new human-centered systems across various domains, from writing, exploratory data analysis, and knowledge search. She got her PhD in University of Michigan. Actually, she got 2 degrees, one in computer science and the other one in information. And she got her bachelor's in science here at University of Minnesota in computer science. For today's talk, she will discuss how she integrates a human-centric understanding in cognition, organization, and social science into human AI interaction design. So please join me in welcoming her with a round of applause.
I feel like it's really nice when you get introduced by someone you also actually know in your life, so I really appreciate it. Thank you everyone for being here at 4 p.m. on a Friday. Hopefully this will be exciting content for a Friday evening. So I want to get started with talking a little bit about what I mean when I say leveraging social theories for human AI, to enhance human AI interaction. By social theories here, I mean an understanding of how people think, communicate, and collaborate. And I use this to design effective and safe human AI interaction. So in this talk, I'll cover 3 questions. What is an effective human AI partnership? How can we make human AI interaction safe? And what can we do to enhance human AI interaction going forward? Some of these things are going to be very briefly covered. So if you want more details on any of it, I'm happy to chat offline. Okay, so let's start with what is an effective human AI partnership. When I think of effectiveness, I think of something that amplifies the complementarity between people and AI. We build in my lab a lot of systems to this effect, and I'm going to give you one example of one such system. So imagine a Q&A for people who are blind or have low vision. They often are looking to get a sense of their surroundings, right? So they take pictures and they send them online for visual Q&A. So they'll send off a query to a system and get a list of answers or maybe one answer on what is in that picture. This can be something like, what color is this? Or what item is this? Or which medication is this? Or what is in this photo? Right. So you can imagine with computer vision techniques, it's pretty easy to answer the first couple of questions. Things get a little dicey when you can answer the last couple of questions because there's private, sensitive content in some of these images. So we decided to try to understand how can we mask some of this sensitive content, right? Because we don't want this content to be available in data sets for other models to use for the rest of time. So basically what you can do is try to obfuscate the image that is sent to a system for visual Q&A, right? So if I had this as my original image, I could maybe mask any potentially sensitive content, but still leave a signal for what's in there under those masks, right? Now, this is incredibly hard to do. One, because computers don't have notions of what's sensitive or what's private, right? So if I just tell an algorithm, hey, mask any sensitive content here, they don't know what that means. Right? And then people are also not always great at this, but also in both cases, you would have to share the original image, right? So that defeats the purpose of doing the task. So what we came up with was this approach where we segmented the images into smaller parts, and we had people, crowd workers, look at one segment at a time. So they had to tell us, okay, is there something sensitive in the little chunk that you're seeing, but also predict if the surrounding cells might have sensitive information. Now, people are good at this because we understand context, right? We understand if I'm seeing a nose in that middle segment, there's likely a face in the surrounding segments, right? So they're able to do this task. And then you can use AI and bounding boxes approaches to figure out which of these boxes then need to actually be sent to other people for verification, right? So if I'm very confident that the surrounding cells are, which ones of them are sensitive, then I don't actually need crowd workers to label every single one of them. So we did this progressively, starting with small segments, going all the way to larger segments, until the point where you could get the full image masked. So that's what I mean when I say something that amplifies the complementary skills of people and AI. What about real world deployment, right? We're building these systems. They're taking advantage of things that people and AI are good at. Can we put them out there? That's a very tough question, right? Because a lot of other considerations come to play when we think about making systems or deploying systems at large scales. We have to assume that these systems can work at that scale, but more importantly, we have to assume that there won't be any bad actors, right? So you could imagine, even with our segmentation approach, someone taking this and going, I can create a platform or a forum where we all come together, share our individual segments, and try to get at the original image, right? So your sensitivity or your sensitive and private content is lost again. So effectiveness is just one piece of the picture, right? We also have to make sure these AI and ML-based systems that we are trying to deploy in the wild are safe from biases of all kinds, right? And the bias that I just mentioned with bad actors is just one of those things. There's inherent biases in the data and the modeling themselves as well. So that's the second piece of my research, where I look at how do we make these systems safe, right, for real world deployment. And that naturally involves looking at the ways in which they're incompatible, right? So trying to understand what will break them, what are the different ways in which people and AI can be good and bad, right? And also then what do we do about it? How do we design better systems? So I'm going to share some projects that we've done on this front with all of you. Let's look at this question of safety. How many of you know about interpretability? Raise your hand. All right, so some people know, but I'm going to give you a brief overview just to get everyone on the same page. One way in which we can make our machine learning systems better or safe is by making them more interpretable or explainable, so that someone who is viewing these systems or using these systems can understand how it's working, right? So that if there's something wrong with it, something's off about it, some reasoning is not quite right, you have a chance of inspection, right, to understand what might be going on. And there are normally two, I'm talking about model-based approaches for this. There's a glass box model, right? So a model that's inherently interpretable, like a linear model where you can say A plus B equals C. If I know B, I can automatically, B and C, I can infer A, right? So you can easily tell what's going on. And then there are black box models, which is most of the widely applicable models like neural nets, anything with deep learning, GPT, right? And these models are not inherently interpretable. But there are some post hoc approaches that try to get at their interpretability as well. So with models like these or approaches of interpretability like these, you can normally get three types of explanations. So if I was, let's say, predicting income based on demographic data, I could get a local explanation. A local explanation tells you about a single data point. So this is one person, the values there are about that one person's marital status, occupation, education. And then the model is telling you, okay, the prediction here 0 means they made less than 50K income. And this is trying to tell you how each of those factors led to that decision for an individual. If you aggregated that for all data points, you can get a sense of how individual features are impacting the income, right? So this is an example of how age impacts income. And then if you do that for all features, you can get a global sense of which features were important for this model to predict things overall, right? Across all data points, which features are important. Here it says things like marital status, age, capital gain are important features for this model. Okay, so now we know what interpretability is, and I'm going to tell you about a study that we did to see if interpretability works in practice, right? We're trying to use interpretability to make things safe. Let's see if that works. So we conducted a study where we first started with pilot interviews to understand common challenges in data science pipelines. So what are errors that people normally identify in data? Then we put these errors in a data set, right? And then we did contextual inquiries where we gave people these interpretability tools and tried to understand if they're able to use them to actually find the errors that we had put in the data. We got some results, and then to generalize them, we did the same thing at a large scale with 197 people to see if our findings held at that scale. So I'm going to give you a very quick overview that you might have expected. Interpretability does not work. And here's what happened. So people misuse and overtrust interpretability tools. Less than 4% of the 197 people in our generalized study could even accurately describe what was in the visuals, right? There was just no large-scale comprehension of them. most people, and these are data scientists, so people who know machine learning, right, overestimated the capabilities of these tools. So we had them answer many questions. One of them was about, what do you think this tool can do? And we gave them a bunch of, answers that they could select. Of these many things, only the things in these boxes are actual capabilities of these tools, right? And as you can see, people assign far more value to them than the capabilities that these tools are designed for, including things like automated detection of fairness issues, which is just not going to be a capability for a long time, right? People also gave our erroneous model very high deployment scores. So when we asked them to think of this hypothetical situation where this model could be deployed for, let's say, a loan approval application, they say, yeah, this is ready to go, right? This erroneous model is ready to go. Now, this is going to be an example of what they saw in the erroneous model. So this is one of the charts that they saw. This is the relationship between age and income. You can ignore this axis for the most part. It's just to give more color to the chart. But this is how age is affecting income in the model that we gave them to inspect. So when you look at this, what do you think? Age and income. Does this relationship make sense? 20-year-old to 90-year-old. Well, it's technically 0, but well, that's, What about it doesn't make sense? Yeah. So immediately, I mean, everyone sees this like weird spike, right? It's hard to miss. And people saw this, right? And still they said this model was ready for deployment. What we noticed that was happening in our qualitative data was that people saw this and were like, I wonder why this is happening. I can come up with a reason why this is happening. For example, by the time you're 40, you've paid off all of your student loans. And that's why you're suddenly making so much more income, right? So the tool worked. It told them what was going on, and it told them something is going off, right? There's an outlier here. There's something going wrong. But they justified it. They came up with these narratives to explain away these oddities that they were seeing.
Why is shaft value for age?
Yeah.
Explain this to me a little bit more. Like, so is age is each definition of like teach age feature?
Yeah. So age is one of the input features for the model. Age, not quite. Yeah, so the distribution is not, and this model, SHAP is a post hoc explainer, so the model we used was also not a linear model. It's a post hoc explanation technique. So SHAP is just a game theoretic way of approximating what is affecting your model the most. And so when you only look at age values, the input feature age and how that has an impact on income, this is like 20-year-olds, not so great because it's negative impact. When you're younger, you're not making much money. As you get older, there's the spike and then it kind of flattens out towards the end. So it's looking at all age across all data points and trying to tell you overall, what does that mean for the model?
I think it's
Yes, it is. So these visuals are not highlighting a lot of literacy, or they require high literacy in machine learning, right? That's why we were working with data scientists, assuming that they would at least have some idea. But even let's say you don't understand what SHAP is, right? You immediately see that spike and you go, hang on, I need to explore this further. Something's going on, right? But instead, what we saw people do a lot more of was, oh, this tool is released publicly by a big tech company. It will just tell me if something's wrong, right? So there was this inherent sort of lack of desire to comprehend and deliberate about what was going on, which is what the tool is intended for. It's intended for deliberation, right? But that was kind of not happening at all. So we were curious about this. We wondered if this is what's the problem, right? Because what we found in that study is interpretability isn't quite working out the way it's meant to be. So we wanted to explore this further. We decided to set up a hypothesis-based experiment to really probe that cognitive function, right? And these slides are from sort of giving this talk before, and I'm sure the next few slides you're all going to say duh, but we'll go with it. So we hypothesized that the bounded nature of human rationality is at play here. People are not really always cognitively maximizing all utility of all features when they make decisions. This is presented as system 1, system 2, often, although there's debate on whether that's the right way of thinking about it. But still at a high level, there's an understanding that there's multiple ways of thinking. One of them is a little bit more heuristic-based, easy, quick decision-making mode, whereas the other is a little bit more deliberate, cognitively effortful thinking mode, right? And if you look at a lot of research in these areas, they consistently say that people prefer the less effortful thinking mode, right? They try to make decisions quickly with the least amount of work that they have to do to get there. So a common heuristic that's mentioned is the availability heuristic, where instead of looking at all the information that is available to you, you kind of select into things that are more recent, more vivid, maybe something that surprised you or something that's negative. Those are the pieces of information that stand out to people, and those are the things they make decisions off of. So we wanted to, structurally study this in a machine learning and interpretability setting. The first thing we did was to try to characterize the space a little bit using this framework. So we used time and cognitive effort, which are the building blocks of behavioral economics theories on the stuff, to map out the space. So when you spend a lot of time and a lot of cognitive effort on something, it's called a maximizing cognitive mode, where you're trying to maximize the utility to you, right? And we believed that a control condition without any interpretability would be this maximizing mode, because you essentially have no help, right? You're going to have to write your own code. You're going to have to inspect your own hypotheses to get to any answers, right? Compared to that, there's the satisficing cognitive mode, where you're spending very little time, very little effort on decisions. You're quickly making them based on prior heuristics or anything that stands out to you in the information that you're seeing. And we hypothesized that what was going on was that these interpretability visuals that we're seeing would fall under that satisficing mode, because they're priming you to kind of just look quickly, everything looks good, let's go, right? So these are the visuals that I showed before. We believe these would be under that satisficing mode. And then there's cognitive modes where you don't have a lot of time, but you have to make very, very effortful decisions, like think of an ER in a hospital, right? We call this the surviving cognitive mode. Luckily, most data scientists never have to operate in this mode, so we didn't really have anything for that quadrant in our study. And then I like to call the last quadrant here sort of optimizing, because I like to think of it as you're spending a lot of time on something, but it doesn't feel effortful, right? So you're maybe enjoying spending time on something. In HCI, which is my field, oftentimes we think of interactivity as this way of enabling that in a system, right? If you make something interactive, if you make something where you have to click and explore and do things to the interface, right? People spend more time and they're more engaged, and there's more likelihood that they're paying attention. So my hypothesis was, if we had interactive tools, right, those would fall under that optimally effortful category. And these interactive tools exist. We tried 2 of them. I'm going to give you a quick demo of one of them, just so you can see the clicks and features available. So here you've got one kind of full set of data points. One of them is selected. You can see the different effects of different features for that data point. Then you can change the values of that data point in real time and see sort of if that data point already exists, if how that prediction would go. Really, the thing to remember here is that there's a lot of clicks, buttons, features, a lot of information that you can more easily access than having to write code for every single bits of these to get visuals, right? So that's the big difference. Okay, so we studied this with a between subjects experiment with 119 people. We had 5 conditions, our control, and then we had 2 conditions each for the visual and the interactive tools. One represented a glass box model, so like linear models, easy to inherently interpret, and one condition for each represented a black box model, which had a post hoc explainer. And we set up multiple choice questions about a data set that people were exploring that they then answered at the end of the study. These multiple choice questions were crafted to have options that would get at some of this heuristic space thinking. So our options included things that were accurate, that you would learn if you were paying full attention, complex answers. But they also included things that were plausible, that you could get to if you were just making decisions about the data set that we used for the study was the Titanic survival data. So if you knew anything about the Titanic, you could infer some things and make a heuristics-based decision, and that were still accurate. But then we picked things that were visually plausible, like catchy attention things in the visuals. Those were inaccurate, right? And we picked things where you would be making decisions about something that happened on the Titanic based on, let's say, the movie that you'd seen or something like that, right? But those were also inaccurate and then randomly inaccurate things. So we had the full range of, hey, you could apply heuristics in a good way, right? Or you could apply heuristics in a bad way. I'm going to go over some results from the study. If you have questions, more questions about the setup, I'm happy to answer them. So one of the things we looked at was time, right? Because time is one of our quadrant shaping things. So as you can see here, people spent far more time in the control condition than any of the interpretability conditions. In fact, they spent significantly more time, 5 times more time in the control condition than any of the interpretability. Now, visual interpretability conditions, which is this orange stuff I expected, the green is the interactive tools, right? And you can see they did not spend a lot of time with those either. We're like, okay, maybe, I don't know, maybe control was super hard because you didn't have any help at all, right? No interpretability, so sure. Let's look at other stuff. Accuracy. Accuracy was also 17% higher in control, and it was a significant difference. So none of the interpretability conditions matched the accuracy of control, right? They were all lower. Let's look at this in even more detail in a different way. So when we looked at which type of answer people picked, right? Whether it was accurate or plausible or inaccurate, you can see most of the control condition, right, had a positive relationship with picking the accurate answer, whereas the interpretability conditions had negative coefficients for those, right? And they had more relationships with these plausible and inaccurate answers. So again, interpretability did not help, right? And let's come back to that quadrant and I'll reason about why with qualitative responses that we got. So first off, exactly what we expected happened with the visual explanation, right? People spent very little time, very little cognitive effort. Most of the times they picked options that were visually very plausible but inaccurate. So they were anchoring to visually what looked the most prominent answer and going with it, okay? What was surprising though was our interactive condition, right? Because we expected more time, less effort, more time, more attention. It ended up being actually falling in that surviving category. Any guesses why? Why didn't it work? I mean, all participants always are. Yes, so that affected all conditions, I want to say, equally. So you're right, there was probably a little bit of that, but there's also something else going on. So what was happening here was cognitively burdensome, letting go of the task and relying on your heuristics. So there's so many options provided by these tools, so many clicks, buttons, information, features, everything changes things, and then you've got to try to understand it. And it felt so cognitively burdensome to people that were like, you know what, I'm just gonna follow my instinct and rely on my past heuristics. So a lot of times these people picked the heuristically plausible but inaccurate answers. So different behaviors, right? But they both resulted in lower accuracy. And what was interesting was that our control condition ended up being more optimally effortful than we thought it would. People actually really enjoyed it. The thing that I'll mention about why it was maybe not as effortful as the normal control is that we had provided some hints for all the conditions. We'd given people hints on how they could access code or what features they could use to get to the code that they needed to write for that section, right? So it wasn't like we were telling them you have to come up with a code. We were saying you do have to come up with a code, but here's a link to a code base that also does this, right? So they were able to borrow some of those breadcrumbs and write their code more efficiently, and they really appreciated that. They said basically that having those hints took care of the Google and Stack Overflow messiness that they would have had to do, so they enjoyed it, and there was no interpretability in this condition. When they wouldn't have had any hints at all. I think if they didn't have any hints, it would probably still be in that maximizing quadrant, right? And maybe a lot of people. I actually, I can't concretely say this because obviously we didn't test this, but I actually think it would have fallen under this bin, right? The same thing as having too much and just giving up versus not having anything and just giving up and relying on your past heuristics. Exactly. That's why I like to call it this optimally effortful mode, right? You've got, and as educators, right, we all know this, you've got to have enough breadcrumbs. Otherwise, if the task is too difficult, people give up pretty quickly. And what we saw consistently was that interpretability in one way or the other led to that mode.
The assumption, though, for that, those conditions to be cognitive is that people are looking for, they are engaged.
Mm-hmm. Yeah.
Their activity shows that they're probably in as much as the others.
Yeah.
So what makes you think that they do that condition is meeting cognitive benefit?
Yeah, and I guess I should have mentioned the time that I mentioned in the chart, right, was just the time that they spent in answering the questions. There was also the overall study time, right? And that was pretty consistent, which is why we were sure that whatever the effects we were seeing, they were still at least somewhat engaged in the task. Yeah. Good question, though. My reviewers also wondered that. Mm-hmm. Yeah. Any other questions? Of course, yeah. I would much rather get questions as I go. It gives me a chance to drink some tea as I'm talking. Yeah. All right. Yeah.
Do people go into these environments and they take them at face value? In other words, do they expect those models to be interpretable or explainable, given that by default, no, there's this huge default. And I wonder how much of that is playing into actually trying to use them to make sense of something that in the outset.
No, I think that's an excellent question. There's obviously a lot of prior experience and user characteristics that could be at play here. Our assumption was that because these are all, again, people who have machine learning backgrounds, machine learning knowledge, they're all machine learning practitioners, right? So data scientists in the field or ML students or data science students. So we were, thinking they're not completely new to all of this. They've all written code and they were happy to write more code in the control condition, for example. I imagine that what you're describing is very, very relevant, especially when you get to end users who do not have ML expertise, which is what we're trying to study now. And we're, trying to design not these kinds of solutions for that because these are very esoteric for that audience. Yeah. Okay. So through these experiments that we continue to run, we're trying to get a better understanding of what exactly is going on. Why is this not working? What are the different things, cognitive or social or other factors that are at play here? But let's get to how do we do something about this, right? This technology is here, it's not going anywhere. AI and ML are a part of our world now, right? And they're going to continue to be deployed in different ways. How do we still make sure that human AI interaction is to some extent effective and safe? My assumption here is that it all boils down to, with this technology, to attention, engagement, and motivation, things that I'm sure you all have a lot of opinions on. So this is where I like to borrow even more so from the other fields that, have studied these topics for many, many years. And just to give you a sense of the questions that I'm trying to understand in those fields, it's, looking at cognitive and learning sciences and trying to understand what makes people pay attention and think critically. Right. Looking at social sciences and thinking about what motivates people, whether that's more intrinsically, right, rather than extrinsic monetary incentives that we see in a lot of these studies, which I don't think are enough to get people to engage. But also looking at organizational sciences, where there's incredible work on how high-risk organizations operate without catastrophes, nuclear power plants, healthcare organizations. They've had a couple of catastrophes here and there, but for the most part, they've been, they've failure-proofed themselves somehow. Can we learn from those experiences, right? And I'm going to tell you 4 kind of design principles that I'm currently working on as a result of looking at some of this literature. One of them is deliberation. people, when they talk, when they communicate, when they engage with each other, are more attentive. Right? Another is playfulness. So when we enjoy something, when things are like games, we love spending time on them. Sometimes when we're skeptical, pissed off, something's like annoying, right? When there's friction in the system, right? We design a lot of technology that feels seamless, right? It just is magically added into my pipeline, everything looks good. Sometimes when there's friction, we pay attention. When something's off, something we don't like. And then of course, when we work in groups, we're better sometimes and then worse in other ways. But there's more than one person looking at the same information, and the potential for someone finding something wrong with it is higher. So those are the principles that I've been thinking about a lot as potential design spaces for solutions. And I'll give you one example of something that we implemented recently. This is under review, so please don't share it outside of this chat. So we wanted to think about what makes people pay attention and think critically. And like I said, deliberation is one way you do this, right? But synchronous deliberation is incredibly hard, right? Getting people in the same room, especially if you want to do that online, right? Where these AI and ML systems are often deployed, it's even harder. So that makes it hard to scale the solution of synchronous deliberation. So we were really interested in, can we have asynchronous deliberation, but still have the benefits of what we know deliberation can offer? Right? So we developed the Socratic large language model. The instructions that we had for this large language model were to follow a purely Socratic learning method, so no opinions or answers were given ever to our participants. And the goal was to help people investigate alternate hypotheses when they were doing a task. The task that they were doing was data annotation. This was for an objective relation data set, and then a more subjective sarcasm data set task. And the analysis that we did was we compared this asynchronous Socratic LLM deliberation approach to a synchronous deliberation benchmark that already exists. It's already published. We had the results already. So our main thing that we did was the asynchronous LLM, and then we just try to compare the results. Okay. Oh, I don't know why that shows up there, but let me tell you the result first. So Socratic LLMs perform comparably on the sarcasm data set. So whatever benefit people got from synchronous deliberation on the sarcasm data set, they also got from our Socratic LLM. The relation data set, actually, we ended up doing better, which was surprising to us. So here's an example of a relation task. Died of radioactive poisoning in London, right? And the task here is to say, did this person live in London? Is that true or false? That's the relation task, right? So lived in is the relation you're trying to determine from this data set. So we had people do this task compared to the benchmark. The benchmark, right? So this is what you're seeing here is pre-deliberation on the left and post-deliberation on the right, right? So relation, because it's an objective task, the deliberation didn't really change a lot of people's opinion in the benchmark, okay? Here's what happened with our Socratic LLM. All of these people who first said the relation was expressed went to relation not expressed, okay? So there was something that happened here with the asynchronous deliberation that didn't happen with the synchronous deliberation. Now, as researchers, I'm sure the first question on your mind is that a good change or a bad change, right? It's a good change. People were more accurate with our asynchronous approach than they were with the synchronous deliberation approach. Is that you're thinking of a question? No. Okay. All right. So they not only kind of, percentage-wise did better, it was also more accurate. This Socratic LLM also resulted in longer engagement from people. So they spent more time, there were more messages exchanged. The Socratic LLM served various roles. It served the role of an argumentation device. People liked going back and forth with it, and it gave them alternate hypotheses to think about. It was also a validator sometimes. So, for example, if they'd had a lot of exchanges with it, right, it wasn't like it constantly kept trying to probe and change your mind. Eventually, it was like, okay, I buy it. You've thought about this, right? So they were looking for that validation when they kept interacting with it. It also served as a cognitive support tool. So LLMs, for those of you who've been testing them out, will often give you a summary of everything that's been said so far before they respond with a new thing, right? So it was almost like that cognitive dump where they would say a lot, they would have this whole conversation. By the end of it, they would have forgotten what they said initially, and it would just summarize everything and say, is this what you still mean, right? And that would give them this sense of, okay, here's what my thought process has been so far, right? And that was helpful to them. And then very interestingly, it also helped them negotiate classification boundaries. So what makes something go from being classified as X to classified as Y? And I want to get into this example in just a little bit more detail. So here's one interaction that happened with a user. So this was for the sarcasm data set. The quote that the review that they were classifying as sarcastic or not was, "Love at first sip, not." And they said, I found this to be sarcastic, like playful, but also decisive. The LLM responded with, okay, I follow your logic there. The title with that phrasing does have a bit of a sarcastic tone to it, even if the review itself is more matter of fact. Let me ask you this. If the title was, didn't like this at all, do you think that would be sarcastic or not, right? And then they responded with, yes, specifically it's the play on the words that I find sarcastic. If the title was that, I would not find it sarcastic, right? So this is a great way of collecting data about those classification boundaries, right? The framing of things, what about it makes you think that this is sarcastic? So that was just one of the roles that the LLM played. We didn't actually think it was going to play this role, so this was a nice surprise for us to find, and this is something that we're now exploring further. This was sarcastic. Yeah, at least in the ground truth, it was labeled as sarcastic. Yeah. Yeah.
Still not.
Yeah, exactly. The nod is like JK. Yeah.
Yeah, that's not, yeah.
Okay, so that was just one example that we did with deliberation. We're obviously continuing more work in that space, but I don't already have projects done on the other three, but I want to tell you just quickly about some projects that we're starting in these other three things as well. So playfulness, we have a project right now where we're working on gamifying semantic prompt perturbation for LLMs. People are really good at semantically changing little things, and that will give them a different answer entirely from, doing a search task with an LLM. And we wonder if making this into a game, right? How many of these can you get? Will also inherently let them see the uncertainty, behind LLMs and how they respond to things. So we're hoping that gamification will serve two purposes: as a way of collecting data about prompt perturbation, but also as a way of making people a little bit more aware of the uncertainty of the LLM itself. So this is something that we've just started building the interface for. We're also trying to counter over-reliance by adding a little bit of friction. We've got a system where we're trying to build data stories automatically with like horror themes. So picking really bad data points that the model messes up on and trying to highlight those before you get into the main task that you need to do. So you're getting at it with that skeptical mindset of, I've got to be careful what I do with this model. We've also got questions around group work. We're first trying to, since group work is so complicated and messy in so many ways, we're first trying to understand, before we even form groups, what do different people bring to the table here, right? So how does an expert versus a novice do the same task? And trying to probe through think aloud protocols, like how are they asking questions, how are they answering questions about data and models? And then finally, we hope to, design these mixed expertise groups to do the tasks better. Okay, so that was a very quick overview of how I've been leveraging social theories to enhance human-AI interaction. Happy to take any more questions. I wanted to do this talk more as a conversation starter, so if you have any detailed questions you want to ask about anything, I'm happy to take details too. Yeah.
Thank you for your insightful talk. Floor is open for questions. We have
Plenty of time.
Yeah. For multiple questions.
So this is more of like an implementation question. because we obviously tested large language models and how they respond to the participants when they're going through the Socratic method.
Mhm.
But there's just there's still a chance that you might blow up in some unexpected ways. So what were kind of practical journeys you might have had while designing the experiment?
Yeah, that's a great question. We piloted this a lot because we were also worried about that, and I'm still not sure that we covered all potential edge cases. Luckily, the experiment itself was not super long, so we didn't have any participants tell us what was this or any kind of negative experiences. But some things that we already fixed was, the LLM would wax poetic about some random thing in the middle of answering these questions, right? It would just go in way too much detail. So we constrained it a lot and said no more than 3 or 4 sentences at a time, right? Another thing it did a lot was it would never accept any answer. It would keep questioning, keep alternate hypothesis, like Socratic method, right? Now, when you've got a task where there's 3 class labels, there's only so many alternate hypotheses, right? So if you, let's say, switch from expressed to not expressed, then it's trying to get you to switch back from not expressed to expressed, then you're like, oh, I'm not sure anymore. So we try to constrain it to once a loop has happened and someone's changed their opinion, verify, but don't kind of re-engage in the Socratic process all over again. And these are decisions that we made just sort of offhand, but I imagine that there's more testing to be done on that front. Right? So we just changed the system prompt to, do some of these things, but I wonder if you can be a little bit more personalized, a little bit more contextualized about these things that we just didn't get a chance to do with this initial exploration. Yeah.
Follow. If somebody changed their mind in the wrong direction,
Mhm.
would the model then still accept their answer or would they go back?
No, we accepted whatever they changed their mind to. We did not try to get to a correct answer. For a lot of these, especially like the sarcasm data set, even though we had some notion of ground truth because it's an established data set, ultimately the goal was to think about multi-perspectivist data sets, right? So there might never be a right answer. All we want for people to do is just consider that there might be different ways of thinking about the question.
Do you think that the results would be different if it was a data set that wasn't like something like I've never actually looked at a Titanic one, but I know that it exists out there. And do you think it'd be different if it was like human collected data instead of from some big data set that already exists?
Could you clarify a little bit what you mean when you say human collected data? Just so I understand what you're distinguishing there.
If you took your data set, for example, and published it and said, here's all the variables, here, you can do whatever you want.
Gotcha. Yeah.
If you want to look at that more critically than a established public data set?
Yeah, that's a good question. I think there's 2 elements to that question. One is it my data set, right? So am I the one who's collected it and then am I the one who's analyzing it? So think about data scientists working in organizations. They're building the technology, there's logs generated from that technology, then they're analyzing those logs, right? So they're inherently more invested in looking at the logs because that's their job, right? So I do think there is probably some difference in behavior there when you've got this, like I said, I think it comes back to motivation, right? Extrinsic and intrinsic motivation, even though just because it's my job isn't an intrinsic motivation for everyone, but certainly you're at least getting paid for it. And then also if you screw up, you have a boss that you have to answer to, right? So that's a bit more motivation than what you would have in a study. So I do think there would be some differences there. That's why we're trying to figure out how to do these studies in more intrinsically or, otherwise motivated settings. And I think the other element you have there is what if this data set you knew was released by someone like that, and then you get access to that data set, right? That one, I have a harder time reasoning about because I feel like Titanic was also technically collected by people and put up there by people, right?
I assume they maybe took out all the problematic variables or variables you shouldn't be I don't know.
So most of the publicly available data sets are tried to release in the original context that it was collected because it's part of the data processing pipeline to think about those problems, right? So yeah, I mean, there's some notion of this has existed for a while, other people have done this before. I'm sure that could lend itself to some more credibility being assigned to that data set. No, I think that's a good thing to wonder about. I don't have a concrete answer. I'm sorry. Yeah. No, good question.
So like the thing about group work is still in the implementation
Mhm.
process, and you're still trying to figure out how to do it. But then my question is like, when you're prompting people to like think about group work, is it more like, oh, think about a time where you're working in a group setting, or are you like asking them like, oh, what do you know about group work?
Yeah, no, that's an excellent question. Right now, the stage that project is in is we're first probing people individually, right? So we're having the expert do the task and the novice do the task individually. The next step is to put them in the same room and observe them together. And only then will we try to craft these groups on our own. But the end goal of that line of work is to put groups together, not just imagine group settings. So we want to start with individuals and try to really understand what their expertise looks like, then craft informed groups, and then study if those perform better.
I don't know where this question's gonna go, but basically, Lauren's question and Mary's question are both making me think about, and we were talking in general, it's making me think a lot about the role of knowledge and expertise in general, and like how you're conceptualizing that.
Mhm.
Because to me, it feels like in this domain, there's like several different dimensions of knowledge that feel like highly relevant to what interventions would work and for whom.
Yeah.
And how to get people to attend to things, where there's like, I know about what neural networks do, or I know what a training set is.
Yeah.
Says, I have validation.
Yeah.
Or I'm working in a healthcare setting, and
Yeah.
I know that this variable should not predict this outcome.
Yeah.
Like, it shouldn't, and that's like, and so I can interpret, I can see errors, right? Like I can see the age spike or whatever.
Yeah.
And probably sometimes the interpretability piece is
Yeah.
more obvious to anybody, even if they don't know anything about machine learning, right? And so thinking about like what expertise is important and how do we think about that when we're doing this, and how domain specific some of these interventions.
Yeah. Yeah, no, I mean, that's an excellent point, and I wish I had solved that problem already, but here we are. But I think we're taking steps to thinking about that, right? So one way in which we've thought about this is we did a study recently that's under review as well, where we probed people at different levels of AI introduction. So we worked with people who started college, and AI, LLMs, Dolly, all of these things are already a thing. People for whom it was introduced halfway through their education, so think juniors and seniors or master's students, and then professionals for whom they graduated without these foundational models is the thing that we were thinking about. Vision models like Dolly and Midjourney were not a thing when they were in school, right? And we try to understand how they do the same task and what they think about and what they think is creative or not creative. And we don't quite have a framework yet because one study is not enough to build a framework, but we've started to identify some of these dimensions. One of them is, like I said, this career stage where things were introduced. Another is just age and generational differences. A third is task profiles. So how complicated are the tasks that you do with these AI tools all the time? For a student, it's your classwork, which seems very low stakes compared to a client-based product request, right? So that changes things and people's perceptions of it. So the thing that we consistently found though was what we used to think as traditional skills and fields, right, are changing. And you might argue that any novel technology, any emerging technology causes these changes, but that's not quite the same as the AI. What we've seen before is not quite the same as the AI we're seeing now, where it can presumably do parts of your task, right, and give you outputs. And unless you're invested in critically exploring whether that output is actually matching the problem it was set to match, right, unless you have that motivation somehow, you have the answer, right? So we're sort of starting to get at those dimensions, but I don't have a fully fleshed out framework of that yet, but we're studying it for sure, because expertise is so complex on its own.
Sorry to follow up.
Yeah.
But like one thing I think about is like some of us do a lot of work in where there's a lot of like data science in education. And what you get is this really interesting like differentiated expertise set where you've got like, I don't know if it's half and half, but like half the people that have data science backgrounds, but very little theoretical.
Yeah.
Like, right?
Yeah.
And so, and then you've got kind of the flip, right, that happens.
Yeah.
And the interpretations and the errors that they would see. in a
Are
model
completely
are
different, yeah.
both happen, right? There's this huge
Absolutely,
blind spot
yeah.
that feel totally opposite of each
Yeah.
other, where so it's not, to me, it's not just like AI expertise.
Yeah.
It's this like contextualize, like, can you do it in the right, like.
Absolutely.
Um,
I completely agree. I think ideally, if we're ever working with AI, we want people from these different expertises to work with AI. I don't know how we do that realistically for every setting. So what we're trying to think about is are there ways for us to capture in some small way the heart of this expertise in the form of questions that people are asking, and then present those questions to the other population, right? Because it's really hard to get all these people in the same room all the time. So can we have at least something from them in the same room all the time?
There is one question from one of the Zoom participants.
Yeah.
The question is, what were the examples of the task that novices and experts engaged
Mhm.
in for the group work? Also, what was the domain, like engineering?
Yeah, no, good question. So this is the study we're running on the group work side right now. We have them doing a data science task on the same income data set that I've been presenting kind of this whole time. So it's just they come together, or not come together, individually use a Colab notebook to explore the data set, tell us how they're exploring the data set. Because again, I think we're not quite ready to put these tools in front of end users who don't have data or ML expertise. So like I was saying, I think we want to eventually probe those stakeholders in some way too. I just don't think it's going to be using Colab notebooks and code and visuals that sometimes even we can't understand.
We have time for like more questions. For the keynote survey that you showed,
Mhm.
what were the participants there?
They were also practitioners.
They were also.
Yep. The less than 4% statistic that I showed.
Isn't that like scared?
Oh, yes, I fully live in a dystopian world. Yeah,
And they're. That's, I mean, the data guidance that they showed.
yeah,
Like, yeah, how common that is and for the.
yes. Yeah, so I'll tell you the backstory behind this project. This was an internship that I did at Microsoft Research. And I went to do this internship. We had collected a team of people. I was the HCI expert. There were 2 ML researchers, and there were 2 data scientists on this research team, right? And we went in, and they had already developed one of these interpretability tools that we had used for this study. And they asked me to come in, and they were like, just tell us if everything's looking good, right? So then I designed the study. And I started small. I was like, okay, if everything's looking good, we'll just see everything's looking good. And it just completely fell apart, right? In the contextual inquiry that we did, people were just mind-bogglingly over-relying on these interpretable tools. But up until that point, no study had been run asking that question. So this continues to be one of my most cited papers because nobody believed at the time that these tools are not working. And then when we did the qualitative study and internally discussed this during my internship, the ML and the data science people were like, no, it's just these 11 people that you've interviewed. It's not quite true. And then I was like, okay, let's run a bigger thing. And then we got these results, and now they're all HCI ML people. So I think we were all shocked because we went into this thinking, how do we make these tools better from a interaction and systems point of view? What we ended up discovering was this is far more of a fundamentally human problem than we're not even going to try to make more complex interpretability outputs when these are not interpretable. And that is where I want to say the field also eventually kind of everyone is talking about this now, and it has separated a little bit into interpretability and explainability. In that interpretability as a term has become more model centered, like is a model interpretable? Can you inspect what's happening, the reasoning inside it, right? And explainability is the more human-centered concept, which is this understandable to a human? Is a person able to take the results and do something that they need to do with them? So I think that was the also diverging point for the field. So in some ways, yes, this was a very dystopian world that I introduced myself to after the study. But at the same time, I feel like now there's a lot more reflection and understanding and care for the human-centered theories that go into this piece. And I see a lot of value in those other fields and what they're doing. Yeah. I don't know if that answered your question, but yeah. Yeah.
The data set that you mentioned,
Yep.
is it like, how would you even consider if something is like sarcastic?
It was, luckily I did not have to consider that. It was already collected, and someone else had done that job for me. So even in the sarcasm data set, they will present the number of people who presented each label. They don't have a ground truth. They have X% of people said sarcasm and Y% said not sarcasm. Because it is a subjective task. So you can't really ever say, it's true that this is sarcasm. Our subjective percentages just met whatever the synchronous deliberation was saying. So that's what we assumed was comparable performance. And then for the relation data set, the relation, there is a ground truth, right? That you can say this relation is expressed in the sentence. There's ground truth to that.
Join me for giving her a round of applause for.
Thank you, everyone. This was a wonderfully engaged audience for a Friday. Thank you. All right, I'm gonna exit out of Zoom. Thanks, everyone.